Saxon Algebra 1, Test 18. Number 1. A farmer randomly chose 4 pumpkins out of a patch of 15 pumpkins. 3 of the pumpkins weigh 15 pounds, 18 pounds, and 16 pounds. What could be the weight of the 4th pumpkin if the average weight of all 4 pumpkins is to be between 15 and 20 pounds? So this is from lesson 82, which is on multi-step compound inequalities. So first, let's set up how we would set up finding the average weight of all 4 pumpkins. So we know we find the average weight by adding up all of the numbers together and then dividing by how many there are. So we know that there are pumpkins that are 15 pounds, one that's 18, one that's 16, and we don't know the 4th one. So we're going to have to represent the 4th pumpkin by a variable. So we have 15 plus 18 plus 16 plus x. And then we're going to divide all that by 4. Now we know we want the average to be between 15 and 20 pounds. So that means that whatever number this ends up being, it needs to be less than or equal to 20. However, it needs to be greater than or equal to 15. So now we got our problem set up and we can just start solving from here. So sometimes instead of creating 2 different inequalities, it's easier just to solve all of this kind of in one step, solve both inequalities at once. So we look in the middle and it's being divided by 4. So to undo that, we multiply both sides by 4. So then 4 times 20 would give us 80. And 4 times 15 would give us 60. And now I'm also going to simplify the inside and go ahead and add up that 15, 18, and 16. And that all adds up to 49 plus x. And then we don't have over 4 anymore because we multiplied both sides by 4. So now we want to get x by itself in the middle, so that means we need to get rid of that 49. So I'm going to subtract 49, but I'm going to subtract 49 from all sides. So our final answer, we're just left with x in the middle. And over on the right, 80 minus 49, we're left with 31. And then 60 minus 41, we're left with 11. So the pumpkin can be between 11 and 31 pounds. Number 2 says, use a table to graph the function. So this is just an XY table. So we're going to write our X and our Y and just choose some random numbers. I'm going to choose, now I notice that this is a negative number and it's squared. So it's going to be a parabola and it's going to be facing downwards. So that's just one thing I already know just by looking at it. So you can kind of double check your work once you graph it. So let's choose some numbers. I'm going to choose -2, -1, 0, 1, 2, just so I get some positive negatives and a 0 in there. And now let's go plug these numbers in and find what our y's would be. So first we have -2, -2 squared. So that's -2 times 4, or -8. Next, let's plug in -1. So -2, -1 squared, that's -2 times 1, or -2. Now let's plug in 0. So that's just going to be 0. Next we have 1. So that's -2 times 1, or -2. Last but not least, we'll plug in 2 squared. It's -2 times 4, or -8. Okay, so now let's set up our graph. If you'll notice, my y's go all the way down to -8. So therefore, I want to leave a lot more space on my negative y's. So I'm going to go ahead and let's start graphing our points. So our first point is -2, -8. So I go back 2 and then down 8. So 1, 2, 3, 4, 5, 6, 7, 8. So right there. My next point is -1, -2. So back 1, down 2. About right there. And then 0, 0. So right there at the origin. And then I have 1, -2. So to the right 1, down -2. And then last over 2, down to our -8. And then we're going to connect these, and you'll notice it makes our downward facing parabola. Simplify the square root of 1,000,000 using powers of 10. So one trick is however many zeros there are, that's how many tens were multiplied together. So since there are 6 zeros, there's 1, 2, 3, 4, 5, 6. So here's a pair, here's a pair, and here's a pair. So that means 3 tens come out of the radical sign, and then there's nothing left over. So we actually don't even need our radical sign. So I'm just going to erase that. So to simplify this, we could say either 1,000, or you could leave it as an exponent and say 10 to the third power. Number 4, they want us to solve. This is an absolute value equation. So remember, absolute value equations, you actually rewrite it twice. 1 just as it is equals 9, and then 1 where it equals the opposite, so -9. Because remember, absolute value can be either in the positive or the negative direction. And notice I just took away the absolute value signs because there's nothing on the outside of those absolute value signs, so I don't really need them now, so now I can just solve like a regular equation. So +2, so x equals 11. If I add 2 over here, x equals -7. So that's your answer, x equals 11 or x equals -7. And you can always plug both of those numbers back in to check. For example, if I plug 11 back in, I would have the absolute value of 11 minus 2 equals 9. 11 minus 2 is 9. The absolute value of 9 is 9. Over here, if I plugged in -7 minus 2 equals 9. And if I add a line, change the sign, that becomes -9. And the absolute value of -9 is a +9. So I know I got the right answer there. Find the product. So this is basically just FOILing, but having a radical sign in it. So I'm going to rewrite this as 3 minus √2 times 3 minus √2. So first, we have 3 times 3, that's 9. Outside, 3 times a negative root squared, so that's -3 √2. Inside, we have 3 times -√2, so -3 √2 again. And then we have -√2 times -√2, so that's +√4. Now I'm going to go through and simplify some things. We have 9, and then if you want to, you can go through and add a line, change a sign. So we really have a -3 √2 plus a -3 √2, which is a -6 √2, plus, and then the square root of 4 is 2. Now you can combine the 9 and the 2. 9 and 2 is 11 minus √2. Now you're done because there's absolutely nothing more you can combine. Number 6, a rectangular rug has a length of 98 feet and a width of 50 feet. What is the rug's perimeter? So if we look at this one, we basically have √98 plus √98 plus √50 plus √50. So that's how you find the perimeter. You add them all together. So we need to simplify all this because right now you can't combine all 4 of them. So we can at least combine these two. We have 2 root 98 plus 2, and these are both 50, so root 50. But now we can't combine these because one's root 98, one's root 50. So let's try simplifying each of these. Now 50, I know I could rewrite that as 25 times 2. And 25 is a perfect square, that's 5, so I know I can pull a 5 out. Because the square root of 25 is 5, so if I pull that out, 5 times 2 is 10, and then I have this 2 left over. Now, if I go look over at this one, I could just find the prime factorization of 98, or if you know that 49 times 2 gives you 98, you can kind of skip some work and rewrite it as this, because 49 is a perfect square, that's 7. And if you pull a 7 out times 2, you're left with 14 root 2. And now we can add these. 14 and 10 is 24 root 2, and it was in feet. Number 7, write a compound inequality that represents all real numbers that are less than -1 or greater than 4. So first let's start with this one. Less than -1. So we want all numbers, or x, that are less than -1 or numbers that are greater than 4. And then if I went to go graph this, I have 0 to my -1 there, 4 here. So we want all numbers that are less than -1, but all numbers that are greater than 4. So notice they're pointing in opposite directions. Number 8 is from lesson 68. It says, Jed opens a drawer containing t-shirts. There are 5 white shirts, 3 blue shirts, 2 red shirts, and 2 gray shirts. If Jed picks a shirt at random, what is the probability he will pick a white or a blue shirt? So first, let's see how many total shirts there are. So we have 5 white, 3 blue, 2 red, and 2 gray. So there are a total of 12 shirts. So we want the probability of a white or a blue. So we know that there are 5 out of 12 shirts that are white. So 5 out of 12, so that's right here. And then there are 3 out of 12 blue shirts. And we add those together. So that becomes 8 out of 12, which reduces down to 2/3. So that's your probability. Number 9 from lesson 85. Find the distance between these 2 points, 2, -3, and 5, 6. So our distance formula, so you're going to have to know this for the test, is x2 minus x1 squared. So you're basically just finding the difference in the x values and squaring them, and then adding them to the difference in the y values squared. So again, it doesn't matter, kind of like with the slope formula, which x you choose to be the second one and which one you choose to be the y. Just make sure whichever x you choose to be the second, its corresponding y needs to be the second y. So let's go and start plugging things in. So for my first x, I think I'm going to use this. Have this one be my 1 and this one be my 2. So I'm going to have 5 minus 2, so the difference in my x's, plus, now I have to choose this y since I chose its x first. 6 minus a -3, so that just becomes plus 3 squared. Now we just start simplifying. So 5 minus 2 is 3. 3 squared is 9. Plus 6 plus 3 is 9. Squared is 81. 9 plus 81 is 90. And now we need to find the square root of 90. So I'm going to break up, I'm going to move it over here. I'm going to break up 90 into 9 times 10 because I know 9 is a perfect square. That's 3. 10 can't be broken down into any perfect square, so it just stays inside. And that's your final answer, 3 root 10, because we can't simplify that anymore. Okay, so this is a polynomial with 4 terms, and they want us to factor this. So we need to separate these into 2 different binomials, and we're going to factor each one. So let's look at this first one, 3x squared plus 9xy. We can definitely pull out a 3 and an x, and we would be left with x plus 3y. Now let's look at our second one. We could pull out a 4, and that's it. And we'd be left with x plus 3y. Notice that these are exactly the same, and that's perfect. That's what we want it to be, because one of our binomials is going to be that, x plus 3y, and the other one is going to be what we pulled out. So the 3x and then that positive 4. So 3x plus 4. And that's it. Remember, you can always check your work by foiling that back out. The stem and leaf plot below shows the ages of students in a cooking class. Find the median, mode, and range and relative frequency of age 35. So to find the median, you could write out all these numbers, or you could just kind of count towards the middle. So I like to do that by going 1, 2, 3, 4, 5, 6, 7, 8, 9, and then count from the end. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, so it's in between these 2 numbers, the median. So the median is in between 30 and 31. So you could find the median by adding those together and then dividing by 2. Or you could just see that the median would be 30.5. All right, now let's find the mode. The mode is just the most repeating. So that one's pretty easy to see that it's this one right here, or 35. Then we need to find the range. So that is the highest minus the smallest. So that would be 49 minus 16, which would be 33. And then the relative frequency of age 35. So the relative frequency is just the percentage of people that are 35. So we already found that there are 4 people that are 35. So I'm going to write this over here. Our relative frequency is 4 out of, and there were 20 ages. So 4 out of 20, which is 1/5. And we want to write that as a percent though. So the relative frequency is going to be 20%. So here's one part of your answer, and here's the other part, relative frequency. Number 12 from lesson 83. Determine whether the binomial below is a difference of 2 squares. If it is, factor the binomial. So first off, it does look like it is the difference of 2 squares, but I also can see that I can factor out some numbers here. 36 and 64 are both divisible by 4. So first, I'm going to pull out a 4 and see what remains. I have 9x squared minus 16. So now, let's just look at the binomial, 9x squared minus 16. Notice that 9x squared and 16 are both perfect squares. So I can rewrite those just to show you as this would be 3x squared and this would be 4 squared. So that right there is showing the difference, it's subtraction of 2 squares. So yes, this is difference of 2 squares. And then to factor it, I'm going to go back and erase this because I was just using that to show you it's the difference of two squares. So we still have the 4 out here. Now, if you know the rules for the difference of two squares, you know that it's just the two different squares, so 3x and 4, and you write it as 1 is subtraction, and then you write 1 as addition, and that would be your final answer. However, if you don't remember that shortcut, you can still find this answer by using the other method, which is just a little bit longer, but it still works, where you have your x, and since there is a number in front of that x squared, remember we take that number and multiply it by our last number. So 9 times 16 would actually be negative 144. But notice there's no middle number, it's just 0. So now we're trying to think what two numbers added together would give you, multiplied together would give you negative 144, added together would give you 0. So 144, I know, let's try 12 and 12. One would have to be negative in order to multiply them to get a negative 144. But if you add a negative and a positive 12, you're going to get 0. So that would work. So this is a little bit longer of a way. I'm going to remember that I have this 4 out in the front, but I'm going to rewrite this binomial as 9x squared. And then my two middle terms are going to be minus 12x plus 12x minus 16. Remember, I create two binomials. I'm going to factor this first one. So I could pull out a 3x, and I'd be left with 3x minus 4. Over here, I could pull out a 4, and I'd be left with 3x minus 4. So we know for the answer, I'm going to erase this. This same binomial is going to be one of our binomials. And then the other one is going to be the two things we pulled out. So 3x plus 4. And then remember, we still had this 4 hanging out up front. So both ways you get the same answer. If you can recognize a perfect or a difference of squares and you know how to factor it, then it's a lot faster. But if not, you can always use the old method using your x. Number 13, use a Pythagorean theorem to determine the missing side lengths of C. So we know Pythagorean theorem is a squared plus b squared equals c squared. So it doesn't matter which leg you put into the a or the b. So I'm just going to do 9 squared plus 12 squared equals c squared. So we have 81 plus 144 equals c squared. That adds up to 225 equals c squared. And remember, to get rid of that c squared, to get rid of the squared, we take the square root, but we have to do it to both sides. So c equals 15. So that is the side length of C. Number 14 from Investigation 9. Choose a factoring method for the polynomial below. Explain your choice, then factor the polynomial. So looking at this, I would know that this is a difference of two squares because you have the first term is a square, it's y squared, and the second term is a square, it's 12 squared, and it's subtraction, so it's the difference of two squares. So if you know your rules, you know that this is then y minus 12 times y plus 12. And that's it. You're done. Number 15 is from lesson 89. Give the coordinates of the parabola's vertex. Then give the maximum or minimum value and the domain and range of the function. So first, let's give the parabola's vertex. So the vertex is the very base of the parabola, which is right here. So it looks like that point, x is 0. So let's write out vertex. X is 0 and y is -2. Then it wants to know the maximum or minimum value. So it's actually going to be a minimum value because it's pointing up. So the minimum or the lowest point, and notice that it's a vertical, so it's the lowest point is going to be our y value, so it's just where your vertex is. So our minimum is -2. And then the domain is all your x values that it covers. Now remember, this parabola will gradually keep going, getting wider and wider and wider to infinity. So it's going to cover all of those x values eventually. So we would say all real numbers. And then the range, now the range is going to be all your y values. However, notice that it's never going to get to any of the y values down below this -2 mark. So we would say all real numbers greater than or equal to -2, because it'll never be any of the numbers less than -2. Number 16 from lesson 88, they want us to multiply. So remember, just like when you're multiplying any fraction, you can always cross reduce, or you could just reduce the fraction first as it is. So like as I'm looking at this one, I can see in the first fraction, we have an x3 and an x2. So that reduces to this just being x to the first. Actually, I'm just going to delete that and write x to the first. And then our y's cancel. So we have 5x over 6 now times. Now let's look at what we can reduce on the second fraction. The x to the 4 and x squared. 4 minus 2 would be x squared, and it's going to stay up on the top since there were more there to begin with. And then the y3 and y2. 3 minus 2 is 1, so that's going to become a 1. It's going to stay on the top because there were more there to begin with. So we have 3x squared y over 10. Now we could even cross reduce now. So look at the 5 here and the 10 on the bottom. 5 goes into 5 once, 5 goes into 10 twice. Then we can reduce the 3 and the 6. That's a 1 and that's a 2. So all said and done, now we can multiply across. We have x times x squared, which is x to the third, y. On the bottom, we have 2 times 2, which would be 4. So we have x cubed y over 4. Number 17, they want us to add these together. So first off, make sure they have common denominators, which they do. So the denominator will stay 16x. And now we can add the two numbers on the top because they are like terms. So we're going to have 8x squared. Now you can reduce some of this. For instance, the 8 and the 16 reduces to 1/2. And then there, to 1/2. And then the x squared and the x reduces. This is really x to the first. So 2 minus 1 is 1. And it's going to stay up here in the numerator. So let's rewrite this so it looks a little nicer. We have 1x to the first over 2. We don't really need that 1 there, so we're just going to rewrite it as x over 2. Solve and graph. So first, let's simplify the left side. We have -7 plus a -3. That's -10 is less than -5x minus 5. Since my x is already on the right side, I'm just going to keep it there and move everything else to the left. So we have -5 is less than -5x. Divide both sides by -5. And we get x is greater than +1. Now I'm going to erase some. Now I'm going to erase some of this so we have room for our number line. So we need to have a 1 here, and I'll do some just negative numbers too. It's going to be an open circle around 1. And then x is all the numbers that are greater than 1 are going to solve this inequality. So we want everything that's greater than 1. So we're going to be pointing to the right because those are numbers that are greater than 1. Okay, so let's do -7 plus a -3 is a -10 is less than -5x minus 5. I'm going to add 5 to both sides. To get -5 is less than -5x. Divide both sides by -5. And notice, because I divided by -5, my sign is going to flip. So my final answer then is -5 divided by -5 is just 1. I'm going to write it over here. My sign flips, and I have my x. So x is less than 1, or 1 is greater than x. Now we need to graph. So normally I like to write these problems with the x or the variable on the left. So I'm going to rewrite that as x, and notice that the inequality sign is pointing at the x. So I want to make sure it's still pointing at the x. And then we have our 1. So here's our 0. And there's our 1, 2, 3. Okay, so it's going to be an open circle around 1. And notice that the inequality sign is pointing to the left. So that kind of helps you know that you're going to be you're drawing your arrow to the left. But also, if you just think about it, x, all the numbers that are less than 1 will solve this inequality. So this way is all the numbers that are less than 1. 19, they want us to solve and graph. So we got a lot going on here, just a multi-step inequality. So let's just take it step by step. Let's look at the left side, and we're going to distribute. So we have 3x minus 6 plus 3x is greater than. Over here, we're going to distribute. Minus 2 times 2x will be minus 4x. -2 times a positive 3 will be a -6. Now let's go and combine any like terms. On the left side, we combine our 3x and 3x. That's 6x minus 6 is greater than. Over here, again, if you don't like these subtraction signs, add a line, change the sign. So over here, we combine our 10 plus a -6. So that's a positive 4, and then minus 4x. So I'm going to move all of my x's to the left side. So I'm going to add 4x. And we have 10x minus 6 is greater than 4. Now I'm going to add 6. And those cancel. So we're left with, I'm going to move it up here so there's more space. 10x is greater than 10. Divide by 10. We get x is greater than 1. Okay, now let's graph it over here. So there's 0, 1, 2, open circle around 1, and x, it has to be greater than 1, so it's everything to the right. Number 20, solve and graph. So we're going to get both sides by -3, and notice we divided by a negative number. So that means our sign flips. -9 divided by -3 is a positive 3. And when we go to graph that, oops, we have 0, 1, 2, 3. And it's going to be a closed circle around 3. And then notice that it looks like the arrow, the inequality sign is pointing to the right. So that kind of gives you a clue which way you're going to be drawing your arrow. And also just makes sense, n has to be greater than or equal to 3. So all the numbers that are greater than or equal to 3 are to the right. And that was the last problem for test 18.